Hi there, let's deal with our next topic, which is looking at mountains. So, what will we learn? We're going to look at the different types of mountains, where they're located around the world. We should also be able to know the difference between an old mountain range versus a newer type mountain range like our Rocky Mountains. So what are mountains? Mountains are parts of the landscape which have steeper slopes and they rise up to 300 meters or more above the surroundings. Mountains are found all over the world. Some will stand on their own, but most of these are volcanoes that rise from islands. The majority of our mountains stretch in what's called mountain ranges. And when mountain ranges are found together, they make up a mountain chain. For example, the Alps, the Himalayas, the Andes, and the Rocky Mountains. There are 4 types of mountains that we need to know. The first, of course, we've dealt with or will already, and that's a volcano. So a volcano is a type of mountain, and we have, as you know, 3 types of volcanoes: shield, composite, and of course a cinder cone. So a volcano in essence is or can be a mountain. Next, we have something called fault block mountains caused by normal faulting in the tension of the rock. Thirdly, we have folded mountains. And finally, we have a mixture of both, which we call a complex mountain range. Let's look at some examples around the world of our first type, which is the volcano mountains. So the Hawaiian Islands are examples of volcano mountains. And so this is a picture of an observatory in the Hawaiian Islands, and same with this mountain range here. Again, more examples of mountains that are volcanoes. Here's an example of a composite volcano, which is sometimes called a strato. Strato, which is a mixture of ash and then lava. More volcanic explosions. Let's talk about the next kind. Rock layers can be pushed or compressed. And what that does is, as you can see here, is it can fold the layers into an upward direction like this. And how this happens is, as you know, the Earth is made of tectonic plates. And those tectonic plates move thanks to convection currents underneath in the mantle. We can cause compressive forces between 2 plates. So if these 2 tectonic plates, maybe the Pacific plate and another plate, if they push against each other, what that can do is that can upheave the plate, and that can cause the layers that make up the plate to be squished, and you can see then that they are now folded. And that can create a syncline, which is a downward fold. Let's talk about faulting for a minute. So hey, picture A here, a block of crust or tectonic plate before being faulted. Picture B shows you after faulting. Note that the block becomes longer and goes upward. And C, an eroded normal fault. Note that missing the gray area. So here's our new mountain range that we've just created from not compressive but tensile forces. So this is the boundary between 2 plates, and one can be heaved upward. So this is called slip faulting. Okay, and this is caused by pulling apart of the plates. So fault block range in Sierra Nevada. Again, another fault block system. Here's another example of, again, one slides upward, the other slides downward, and that creates these really up and down fault block mountains. Another kind of fault is more horizontal that occurs, and so this is a thrust fault. So one slides upward and the other slides underneath, more horizontal than vertical. Here's a good animation of how that might occur. So these cause what's called folded mountains. And so the rock layers aren't snapped at all, they're just kind of folded like this. So the difference between the previous type of mountain and these is there's no sort of snapping of the rock. You can still follow the layers as they're still slightly connected but folded. And an upfold is called an anticline. An anticline. And a downfall is called a syncline. This is an anticline. A syncline would be folding that went down like this. So all the curves would go downward. And that's a syncline. Syncline. You can see these. There's folds and they're headed downward. That would be an syncline. These are upfolds. So those are upfold mountains, and that's an anticline. Folding, they're all pointing upward. These ones from above are alternating between syncline and anticline. The final group of mountains I want to talk about are complex mountains, and they tend to have a little bit of everything. Some volcanoes in there, some folded mountains, and some fault block mountains. And so again, here's the difference. So if you look at the fault block mountains, here's folded mountains. Folded mountains, still you can see the layers there. You can see that they're forming an anticline here and maybe a syncline here. But faulted mountains, there is no continuation here between the lines. This has been thrusted upward. Okay, here's an example. These are the Cascade Mountains, and these are fault block mountains which have been thrusted. But look at these ones. These are folded. Look at how well they're folded up and down to create synclines and anticlines. Here's a domed mountain. So you can see this might be a magma bulge here. Let's talk about the difference between old and new mountains. So which one of these do you think is newer? If you pick this one, you're right. And this is an older mountain range, thousands of years older. And what do you notice is the difference here? Older mountain ranges obviously have been eroded and worn away, and they're less peaked and jagged. Ecological succession has taken over, and there's way more vegetation on an older mountain range. This is a newer mountain range. Vegetation hasn't creeped up to the tops of the peaks. There's much more rock layer, and it's jagged and more peaked. So new mountain ranges versus old. Less erosion, more erosion. Less vegetation, more vegetation. Let's talk about where mountain ranges occur around the world. Our tectonic plates that we've talked about earlier on are the key to locating where most mountain ranges occur. So here's some major mountain ranges around the world, and what we would notice is they're just to the right or left of a tectonic plate. To the right or left. So the Pacific plate sort of is the Pacific plate goes like this, kind of around. There's the Pacific plate with the ring of fire. And what happens is it's butting up against another plate and it's causing this plate to be folded that way to make up the Rocky Mountains. Same with here. Most mountain ranges are just past the boundary between two tectonic plates. Let's look at the video clip on mountains.
You got that right. That is a pretty unusual mountain range. Dear Tim and Moby, what can you tell me about mountains? From Jack. Mountains are one of the basic types of landforms. Almost 1/4 of all land on Earth is covered in mountains, and they have a major impact on the environment. Most of the world's major rivers are fed by melting ice and snow from mountains. And because mountains form natural wind barriers, they impact climate and weather around the globe. One example of that is the Sierra Nevada range in the western United States. Winds blowing in from the Pacific Ocean lose their moisture on the western side of the range. As a result, much of the land directly east of the mountains is desert. Well, mountains are classified based on how they form. The Earth's crust is divided into huge sections called plates. There are 7 major plates and lots of little ones. These plates move around very slowly, and that movement is called plate tectonics. Mountain ranges form where plates shift, pull apart, or push together. Lots of times you can tell how a mountain was formed just by looking at it. When tectonic plates converge toward each other, you get folded mountains. The Himalayas in Asia are a folded range that began to form about 45 million years ago when the Indian plate collided with Asia. Those sharp peaks and ridges are signs of upwarped mountains. They form when forces inside the Earth push up parts of the crust. Over time, the rock is exposed and weathered. Many parts of the Rocky Mountains are upwarped. Fault block mountains are made of huge tilted blocks of rock separated by faults. A fault is a large crack in the rock where movement happens. Most fault block mountains, like the Basin and Range region of the western United States, form where tectonic plates pull apart. When molten magma is forced through cracks in the Earth's crust, it cools in layers. The layers form a cone shape over time. That's a volcanic mountain. The volcanic ocean ridge system is easily the longest mountain belt in the world, stretching all around the planet. As these volcanoes push up magma and form new land, the plates on either side of them spread apart. Unfortunately, all that underwater volcanic activity can cause earthquakes and tsunamis. Okay, well, that's it for mountains. Have you got other cool things to show me?